Hello my dear student, how are you? I hope you are all will be fine. Welcome to our channel. Thank you. Let's start today's topic. Today's topic is nucleophilic substitution reaction, lecture number 1 of nucleophilic substitution reaction. In this series and today's series, in this series nucleophilic, all the lectures of nucleophilic substitution reaction will occur with very details. First of all, there are what is nucleophilic substitution reaction. Here will be two different types of nucleophilic substitution reaction will be explained with very detail. With what one is called Sn2 reaction, while the another is called Sn1 reaction. These two types of reaction here actually in this will be this is represented in this form. This is capital S and now small subscript n, capital N will be written like that, and 2 will be like that. That can be represented like that. This is called Sn2 reaction, while this is called Sn1 reaction. Yeah, what does this mean? This mean S means used for substitution reaction, substitution. N used for nucleophilic, nucleophile used for nucleophile, while 2 used for second order, 2 used for bimolecular, 2 used for bimolecular, while here S used for substitution, N used for nucleophilic, 1 used for unimolecular, So the reaction become nucleophilic substitution by bimolecular nucleophilic substitution reaction, while unimolecular substitution reaction. Sorry. Here this is Sn1 reaction is called unimolecular substitution reaction, while Sn2 is called bimolecular nucleophilic substitution reaction. So let's start the Sn2 reaction. What is Sn2 reaction? First of all, the nucleophilic substitution reaction. A nucleophilic substitution is the general form of nucleophilic substitution reaction as this is nucleophilic attack will occur. This is nucleophile having one lone pair. Also you can write negative charge and nucleophile plus. This is substrate C, where one is a halide ion or leaving groups. This is called leaving groups or halide. This is called substrate. This is called nucleophile. This is called nucleophile. While the reaction, the product will be this halide ion will be replaced by this nucleophile. So the product will be C plus X negative. Here will be 4 lone pair. So this is called product. This will be product of the reaction of the nucleophilic substitution reaction, while this is be called leaving group. So this is the general form of nucleophilic substitution reaction, in which substrate is the compound. Substrate can be defined as a, while here is substrate can define as here is electrophile present. This carbon will be act as electrophile because of nucleophile attack on this carbon, so it will be act as electrophile. Also here is a halogen, strong halogen group attached. This will be like that. This halogen group which is highly electronegative element, so that will be the electron withdraw from the carbon, so that carbon will produce partial positive charge and this halide will produce partial negative charge, and due to on this carbon partial positive charge, that will be act as a electrophile. So if when this is act as an electrophile, that will be act as separate because the nucleophile attack on this electrophilic center, or nucleophile attack on this electrophile, so this will be act as substrate on which the nucleophile attack, while then this leaving group, this halide group will be replaced by this nucleophile and the product will be formed. Also leaving group will be leaved from the substrate. Is it clear? This is called nucleophilic substitution reaction. While here is two different types of nucleophilic substitution reaction. One is a unimolecular nucleophilic substitution reaction and one is bimolecular nucleophilic substitution reaction. So let's start first bimolecular substitution reaction. What is bimolecular substitution reaction? Let's start the topic. Yeah, the abbreviation of Sn2 reaction as I already told you that nucleophilic substitution is used for substitution and used for nucleophilic to use for bimolecular. So the abbreviation become bimolecular bimolecular nucleophilic substitution reaction. This is the bimolecular nucleophilic substitution reaction. Sn2 reaction is the bimolecular nucleophilic substitution reaction. This reaction complete in single step. This reaction complete in single step. Complete in one step. Complete in one step. We will explain later this with very detail. These types of reaction are complete. These types of reaction are completely complete in single step or in one step. So complete have done in single step. Here, what is meant by bimolecular reaction? Bimolecular mean the term bimolecular means that the transition state of the rate limiting reaction, a rate limiting step involves the collision of two molecules. The transition state of the rate limiting step involves the collision of two molecules. Bimolecular use for transition state of the rate limiting step involve the collision of two molecules. Mean here is in reactant there will be two reactant used. Like I already told you that one will be nucleophile and one will be substrate. So when one base substrate containing one leaving group or one halide group, this halide group will be removed, or this halide group will be replaced by, or this halide group will be substituted by this nucleophile. So here in as a reactant, two reactant used as a reactant and this types of molecules. So that's why this is called bimolecular, and that's why the word term 2 is used for this reaction, Sn2 reaction. And Sn2 reaction, two substrate will be used, two reactants will be used as a reactant to form transition state. After the transition state, directly product will be formed. While this reaction will be complete in single step, only in one step it will be completed. Yeah. And experimentally bimolecular reaction usually have the rate equations that are second order reaction. Usually bimolecular reactions are bimolecular reactions have rate equation that are second order. Yeah, usually the bimolecular reactions have a rate equation that are second order. Means the Sn2 reaction mostly will be these are second order reaction. It means shortcut, it means that mostly of Sn2 reaction will be second order reaction. These reactions mostly are usually, you can say that you can use the word usually or mostly the Sn2 reaction will be second order reaction. And also you can use the another term that SN2 reaction will be have we two second two molecularity. The molecularity of the SN2 reaction will be 2 because two molecules are used as in a reactant. Sorry for today. Today is my throat disorder. Uh, I'm really sorry. You can take screenshot from this. Also, you can write on your notebook. Also, you can pause. You can rewind the video. Due to lack of space, uh, I am clearing the board. Let to proceed the topic. So the rate of SN2 reaction can be written as rate of SN2 reaction can be written as the reaction is here is nucleophile that is attack on that is nucleophile that is attack on substrate means these two are a reactant that are used. Let's suppose that the substrate is Rx. If this is substrate in general form, so what will be the product? The product will be nucleophile plus R plus X halide will be the leaving group. So the rate for this reaction, rate for second order reaction, it will be directly proportional to the product of the reactants that is nucleophile and the substrate, or you can use Rx. So that's why rate will be directly proportional to the nucleophile product of these two reactants which is nucleophile and substrate are Rx. So rate will be equal to K into nucleophile negative Rx. This will be the rate law for the the rate law for the SN2 reaction. Let's here is one example that is when OH group when OH is a nucleophile used plus methyl iodide used as a substrate. The product will be CH3OH CH3 plus iodide will be the leaving group. So for this reaction, experimentally the rate is the rate can be defined as the formation of product the formation of product um, per second or per unit time, or the decreasing in the concentration of the increasing in the concentration of product per unit time is called rate, or you can say that the decreasing in the concentration of reactant the decreasing in the concentration of the reactant per unit time is called rate. This called rate. So here experimentally the rate is increased by either for this reaction by either uh, double the double the concentration of the reactant area of the reactant either of the reactant its rate will become doubled. It is experimentally, so the reaction will become double, or because it is also increased by one time. It is also increase the power of one, because by increasing one time by increasing double concentration double, the rate become double. Also when this is increased by double time by two times, the rate of reaction also become two times. So for this is order, for this molecular is order 1, for this is order 1. So the total order of the reaction will be second order reaction, two order, because order can be the order can be addition of the summation of all the order of all the reactant that rate depend upon their concentration, rate depend upon their um, concentration, that may be double triple. When we sum all these things, that will become the final order. So it will be second order reaction, because this is one, this is one, this is increasing. When OH increase up to one time, when OH increase up to one time and CH3I in increase up to one time, so the reaction will become, when the concentration of OH double and CC3I double, the product will be four times 4 times because this is increased by double and this is the rate increased by double. The product, the reactant will, the rate of the reaction will also be increased by 4 times because 2 power 2 will be equal to 4 times. So this means that for this reaction, for most reaction, the SN2 reaction will be second order reaction. I hope it will be cleared. So now let's start explain one example of this SN2 reaction. Let's suppose the SN2 reaction, example of SN2 reaction. This is the one nucleophile OH group. This is nucleophile. This is nucleophile plus this is substrate C H H H. This is substrate and here is the iodide ion. Iodide ion is partial negative charge because it is most electronegative element. Its electron withdraw from the carbon atom, electron withdraw from this bond, so that's why it become partial negative charge and the carbon will be become partial positive charge. That's why the carbon can act as an electrophile. So that's why OH group nucleophile attack on this electrophile center. Is it clear? After that, what will be happened when this reaction, when this lone pair or when this negative charge attack on this substrate, on methyl iodide? You can use the word methyl iodide. This is hydroxyl group or you can use nucleophile. When this nucleophile attack on this electrophile, so here sorry so here this iodine is most electronegative. Iodine is compared to carbon, this is the most electronegative element. So that's why this iodine, this atom will withdraw electron from this carbon. That's why this iodine become partial negative charge and this carbon partial positive charge. When there is partial positive charge, this mean partial positive mean that there is electron deficiency. Electron deficiency means that is electrophile. So that's why this hydroxyl ion or nucleophile will be attack on this carbon. After the attacking of this carbon, as the nucleophile attack on this carbon, the bond between carbon and iodine will become broken and here transition state will be produced. Now it means that here nucleophile will be attacked on carbon. It will be represented by a dotted line, yeah, like that. That is carbon, but that is hydrogen. This is hydrogen, another hydrogen, and this is iodine. This dotted bond mean that the bond between carbon and nucleophile are partially made, while the bond between carbon and iodine are partially broken. So this state is called transition state. After this transition state, the final product will be produced. The bond between nucleophile and carbon will become perfectly bonded. It will become while the bond between carbon and iodine, it will be broken completely. It will be formed completely. The bond between carbon and nucleophile, this bond will be completely formed, while the bond between carbon and iodine will be completely broken. So it will be like that. CH plus iodine is a negative. This is the phenomena of SN2 reaction. First of all, hydroxyl ion or nucleophile attack on this group as just they are taking the bond between carbon and iodine, or the bond between carbon and the leaving group, it will become polarized and it will become broken. The transition state will be obtained. Here the bond between nucleophile or hydroxyl group here is hydroxyl group are used. So hydroxyl group, that will be bond between carbon and hydroxyl group will be partially formed, while the bond between leaving group and carbon or iodine and carbon, it will be partially broken, and this state will be called transition state. After that, the bond between leaving group and carbon, that will be completely break, while the bond between hydroxyl ion or nucleophile and carbon, it will be completely formed. So here that will be hydroxyl, that will alcohol will be formed. This is alcohol, methyl alcohol or methanol. Here methanol will be formed and iodide will be formed. Iodide ion will be formed. So this is the Sn2 reaction. This is the reaction of Sn2 reaction. But here this is experimentally the activation energy. What is activation energy? Let's start the new topic. Mostly the Sn2 reaction in nature, this is exothermic reaction. Means exothermic reaction means the energy will be lost after the completion, after the once the reaction complete, the energy and final the energy will be lost. Means the energy will be lost. Energy will be lost. It means the energy, the system will be cooled and surrounding will be heated. Means energy from system to surrounding, energy will be lead from system to surrounding. Energy will be lead from system to surrounding. Means that the reaction will be exothermic reaction. It will produce heat. It means that the uh, once the product is formed, it means that this energy will be exothermic energy will be released. When the energy is released, it means that the energy of the product will become lowered. When the energy of the product become lowered, that's also mean that the product will become more stable. So you can, now you can draw the energy reaction energy diagram for Sn2 reaction. It will be like that. So the energy profile, energy diagram, reaction energy diagram become, it will be like that. This will be the energy diagram. Here it is energy. This is energy, and this is the reaction coordination, reaction that are produced, reaction coordination, reaction in which the direct reaction are proceeded. So first of all, here in this, from this position, this is the initial position of the reaction. This is the initial position of the reaction where HO react with, where nucleophile react with methyl iodide. Methyl iodide. This is methyl iodide CH3. This is the initial state. After the initial state, when is just the hydroxyl ion or nucleophile attack on the electrophilic center, on the nucleophilic center on this carbon, partial positive carbon, as this nucleophile attack on this, after that the bond between carbon and hydroxyl ion will be partially formed, and the iodine, the bond between carbon and iodine will be partially break, they partially break, and the state is called transition state. So the transition state will become, so the transition state will be like that. This will be transition state. This is the transition state position. Here the transition state will be like that. This is the transition state. HO, this is partially bond will be formed between carbon and hydrogen. CH, this will be partially break, the bond between carbon and iodine. So this is the transition state. This is the transition state. While the transition state is the state where the energy is maximum. This is, in this state the energy is maximum because here is carbon bonded with 5 different compounds, with 5 different groups. So that's why the energy of the this state will be high state. After that, the bond between carbon and hydrogen, the bond of carbon between iodine, it will completely broke, and the bond between hydroxyl ion or nucleophile and carbon, it will be completely formed, and it will last most energy, the energy from the position of the initial state to the transition state. This energy state is called, this state is called, this energy is called activation energy. Mean the energy that is required, activation energy, the energy that is required, that the reaction proceed, that the reaction carry to to the transition state. After the transition state, the transition state will become lost the energy and produce product. The product will be like that. This is the product position. This is HOCH3 plus I negative. This is the product. So it means that the energy of the initial position and energy of the final position, the energy difference become negative. It means that the energy of the system are lost to the surrounding. So that's why this system is called, the SN2 reactions are called exothermic reaction. That's why this are called exothermic reaction. While activation energy can define as the energy, energy that can be that minimum energy that can initiate the reaction. Initiation position is the transition state. The transition state is the initiation position. So energy from the initial state to the transition state, this energy is called transition state. Or you can say the position of the transition state is the energy barrier. It is called this energy barrier. Energy barrier mean it is the energy, it is those barrier after the reaction, which in which the energy barrier crossed. After the reaction will be proceeded by itself, not by external energy. It will be proceed itself. So this is the energy diagram, energy diagram for SN2 reaction. Energy diagram, reaction energy diagram, reaction energy diagram for SN2 reaction. I hope you all will be cleared. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal Gmail or WhatsApp that I put in description box. You can get from the description box. And also please support me, subscribe my channel. If you have clear concepts, if you like my teaching, then please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck. Thank you.